Good morning, students. In the last class, we discussed about the preparation of carboxylic acid. So, in the today's class, we are going to discuss about the properties of the chemical properties and physical properties of carboxylic acids. Okay. So, I'll go with the chemical properties. So, in the chemical properties, the first one is esterification. Okay. Second one, reaction with Bcl5, Pcl3 and SOCl2. Next. Third one is reaction with ammonia. Fourth one, reduction. Fourth one is reduction. And the fifth one, acidity of acids or acidic character of acids. Okay. And the next one. Okay, this is for what? Aldehyde compound. Later I will explain. Effect of electron withdrawing group and electron releasing group. Effect of electron withdrawing group and electron releasing group on acidity. Okay, and the last one, nitration or benzoic acid. This is for especially aromatic, and bromination. Bromination of benzoic acid. Okay, nitration of benzoic acid and bromination of benzoic acid. Okay, so listen, this is esterification. We will go with one by one. So esterification nothing but formation of esters. In the last class preparation I told you, when alcohol when what is that? Ester undergoes hydrolysis, they form alcohol and carboxylic acid. When they react in presence of dilute acids. So if the reaction is reversed, that is the esterification reaction. That is what I explained in the last class. So here the reagents are, one is carboxylic acid, another one is alcohol. I'll take in this manner. Okay, ROH, RC double bond OH. Okay, so here we are using concentrated H2SO4. The reason for the addition of concentrated H2SO4 is to remove water molecule. Esterification reaction is a dehydration reaction. Dehydration means water molecule is removed from the reactants. So OH is here, OH from here, H from here, or anything. Or OH from here or H from here. H2O will remove. So then what happens? R C O R. Okay? R C O O. If you want to write this one in this form, this is double bond O. Okay? This is here double bond. This is a ester. Plus what? H2O. So from the reactant, water molecule is removed. The dehydration of carboxylic acid as well as alcohol in presence of concentrated H2SO4 results in the formation of ester. That's why this reaction is called as esterification reaction. So you write here, this is carboxylic acid. Okay, this is alcohol. And this one is ester. Okay. So how can you write here? Carboxylic acid and alcohols reacts with each other in presence of concentrated H2SO4. Okay. Upon dehydration, they form esters. Okay, this reaction is called as esterification reaction, you write. So if you want to take the example here, I'll take acetic acid, that is CH3, C double bond O, OH, and ethanol, means C2H5. Okay, this is acetic acid, this one is ethanol. Okay, when they are made to react with concentrated H2SO4, what is the product formed? Here this CH3, C double bond O, here C2H5, this one. CH3, C double bond O, C2H5 plus H2. So what is the name of this compound? Listen, CH3COOH. This is acetic acid. If H is removed, listen here, CH3 C double bond OH. This is acetic acid. If H is removed, then it becomes acetate. So this H is replaced by what? This C2H5. What is this C2H5 group is called as ethyl. The name of this is ethyl acetate. Or in the IUPAC name, if you want to write, this is ethyl. Your two carbon atoms means ethanoate. Ethyl ethanoate. That is the name of the compound. You may write ethyl acetate or ethyl ethanoate. This is the correct one according to IUPAC system. Okay. So this is what esterification reaction. So instead of this R group, as I told you, this is the aliphatic compound. You may take aromatic also. Any one is aromatic, not both. Okay, either this or this. Then you will get the. But most of the time they'll ask, explain the esterification. Listen, you didn't remember this. Write the general reaction. Write this one. If you don't know the name of these compounds, remember. So here I'll simply write ester. This compound, this is carboxylic acid. So by writing this explanation, if you write the example, you will get complete marks because they consider this one as the explanation. With an example means this is the general reaction, explanation and example. Then that is correct. Without writing this, if you write only this without explanation, you will get off marks. Understood? Because explanation is also necessary times. They will mention explain esterification reaction with an example. Then explanation is needed. Write the reaction. Only reaction is needed. Understanding question is different. Is also important. Write the reaction means if you write the reaction with the name, that is enough. If they said explain, you have to explain in words. So if you don't know the name of these compounds, write the general reaction explanation and with an example you will get full marks, as I told you. So if you know the name of the compounds, then no need to write the general reaction and the explanation of general reaction. Just you write this reaction and their explanation. Like what? Carboxylic acid means acetic acid. When acetic acid and ethanol reacts with each other in presence of concentrated H2SO4, upon dehydration, They form ethyl ethanoate. Then you will get full mix. And so this is the way to answer in the examination. This is esterification reaction. So the next one is reaction with So here students, up to this I will take only aldehyde compound, means only aldehyde compounds, not aromatic. These two is specially meant for aromatic. Okay? Next one is reaction with Bcl5, Pcl3 and H2Cl2. Listen, I will take here RCOOH plus PCl. Okay, so for this, there is no reagent here, they will just simply react with PCl. What is the reaction? I will take like this. Okay, here also bond breaking will take place, here also bond breaking will take place. Understood? Only here takes place R C double bond O C R COCl. This one acid halide plus POCl3 plus HCl. Means bond breaking takes place here as well as here. See, RCOCl means this one, RC double bond O Cl. Next, POCl3. Another one is HCl. This is the product. If it reacts with PCl3, okay, they form. So listen here, 3 moles of HCl2. R C double bond O Cl. Same. This is 3 moles plus H3P. This is 3 moles and it is balanced. If it is reacts with PCl3, they form RCOCl. Of course, bond will break here. They form RCOCl, acid halides. Next, H3PO3, phosphoric acid. When they react with PCl3. So if they reacts with SOCl2. Okay, of course the bond breaking takes place in between these two. They form RC double bond O Cl, acid chloride plus SO2 plus HCl. Okay, so here the byproducts are different students. This is also yes, this is also. We don't bother about the byproducts. If it is reacts with phosphorus pentachloride, phosphorus trichloride as well as thionyl chloride. Okay, SOCl2 means thionyl chloride. They forms acid halides, acid chlorides as a byproducts or products. So listen, R C double bond O Cl. All are acid chloride because here in the reagent chlorides are there. So when it reacts with carboxylic acid reacts with phosphorus pentachloride, trichloride as well as thionyl chloride, the product formula is what? Acid chloride. The reaction takes place in this manner. How can you say? Listen. When this carboxylic acid reacts with phosphorus pentachloride, it forms acid halides. Okay, if you don't know this, you may not write. If you know the name of this is phosphorus oxychloride. Then HCl. If you know, you can write. If not, you may not write also. It will be okay. You need only reactants and the main product. Okay. So when carboxylic acid reacts with phosphorus pentachloride forms acid chloride. Here, when the carboxylic acid reacts with phosphorus trichloride, they form again acid chlorides. Remember here, Cl is there means we have to write acid chlorides. Next, when carboxylic acid reacts with thionyl chloride, then also they form acid chlorides and SO2 and HCl. This is phosphoric acid. This is sulfur dioxide and HCl. So students, among these three, the better way for preparation of acid chloride is this one. Third reaction is, in this the production of product is somewhat pure. Here we will get mix up of these two. Here we cannot get the mixture of these three because these two are gases. I write the simple here. HCl is also gas, SO2 is also gas. When they are in the gaseous form, they easily escapes. So the product remained is only what? Acid chloride. So the best way for preparation of acid chlorides from the carboxylic acid is by treating with thionyl chloride. It is important for 1 mark. Why? The preparation of acid chloride from carboxylic acid using thionyl chloride is a suitable reaction. Why? Because the byproducts formed here are the gases, they easily escapes and the product formed is 100% pure. Understood? So this is the general reaction. They won't ask any particular explanation. They'll just give this carboxylic acid and this and complete the reaction type. I'll give the example here. That assume this is acetic acid plus Bcl5. Complete the reaction type. Okay, this type of questions they are going to ask. Among these three, only these three. Okay, what is the answer here? It is CH3, C double bond O, Cl plus POCl3 plus X. Okay, listen. Here they won't give the balanced reaction. That is CH3, C double bond O, OH. Or they simply give, instead of that, they may give COOH. Here they will give only PCl3. Okay, so listen. Instead of PCl3, I write the products here. That is R, CO, Cl plus H3PO3. Then you have to write which reagent is going to take an here. So H3PO3 is the byproduct. Then this must be what? PCl3. So PCl3 means it is not a balanced reaction. Sorry, here it is CH3. Then here you have to take 3 moles, here you have to take 3 moles. This is the way they are going to ask the questions. They ask the reactants, they ask the products. Here they ask products, here they ask reactant, like that. By taking product, by comparing product, reactant, you have to write the balanced equation. Understood? Here also say, we take acetic acid here. That is SOCl2. They form what? Same. CH3, C double bond O, Cl plus SO2 plus HCl. If you know the general reaction, you may replace the dark group by any of your choice. The general reaction is important. That is what? Reaction with PCl5, PCl3 and SOCl2. Understood? So the next one is reaction with ammonia. reaction with ammonia. So listen students, initially what happens? This RCOOH, when it reacts with NH3, so they form SR, that is RCOONH4. This is minus, this is plus. This type of salt they will form. Quaternary ammonium salt or ammonium carboxylate. Ammonium carboxylate. Understand? Later, upon decomposition, understood? They form RCO NH2 plus H2O means amide. This is ammonium carboxylate. This is of course carboxylic acid. This is ammonia. Okay, so when carboxylic acids reacts with ammonia, they form carboxylate ion, and upon decomposition, they give amide. Understand? So listen, if you take example, that is like acetic acid here, COOH plus NH3. They form, what is the product here? The intermediate CH3COOH is the reagent. Then what is the CH3COOH4? This is plus, this is minus. Next, upon decomposition, it gives CH3CONH2 plus H2. Listen here. This is of course acetic acid we know, or ethanoic acid. This one is ammonia we know. This one is what? Carboxylate means acetate. Ammonia acetate. Ammonium acetate. Okay, and this one is acetamide. How can you say the explanation? When acetic acid reacts with ammonia, forms ammonium acetate. Upon decomposition, gives acetamide and the water molecule. Water cannot be. You can write. You may write. You may not write. That is not important. This is important. But when acetic acid reacts with ammonia, they form ammonium acetate. Upon decomposition, you may write here heat is there, thermal decomposition. We are supplying heat here. Then you can say thermal decomposition gives acetamide. Understood? This is what reaction with ammonia. The next one is reduction. So for reduction, as I told you, only platinum or palladium catalyst is there, or lithium aluminum hydride or sodium borohydride are going to be used for the reduction, right? So reduction means what? Either removal of oxygen or addition of hydrogen. So this one is reduction. We have to say means here we are going to use lithium aluminum hydride as a reagent. Sorry, catalyst. Okay. So remember here, RCOOH is there. Reduction means addition of hydrogen takes place. Why we are writing this type of hydrogen? So listen, remember, if we take H2 like RCOOH plus H, the potassium, platinum and palladium are the catalyst because we are using H2 gas. If you take the hydrogen is written in a square bracket, we must use lithium aluminum hydride and sodium borohydride because so lithium, which one it is? Lithium aluminum hydride. So dissociates like what? Lithium aluminum H3 minus plus H plus like that. Understood? So means they form this type of nascent hydrogen. Nascent means alone, neutral molecule, not plus, of course. Like ALH3. They liberate what? Nascent hydrogen. If in the reaction, if it is written like this, then we have to use lithium aluminium hydride or sodium borohydride as a reagent. If instead of this, if we take H2, we have to take platinum or palladium as a catalyst. Understood? So here, what happens? Removal of oxygen and addition of hydrogen takes place. This one R CH2OH means carboxylic. They form alcohols along with liberation of H2. So students, how many hydrogen atoms are added here means year to year. Total 4 hydrogen atoms. Understood? And carboxylic acid undergoes reduction in presence of lithium aluminium hydride, they form alcohols. Okay, so example if you want to take, that is CH3COOH plus 4H. Then what is the reagent? Sorry, product formed here? CH3, CH2, OH plus H2. So name of this compound? CH3COOH? Acetic acid. Or in the right here 2 carbon atoms are there, so ethanoic acid. So this one is 2 carbon atoms with 1 OH group. Ethanol. So I'll take another one example here. CH3, CH, CH3, COH. This type of branch example I took here. So then what is the reagent? Sorry, what is the product formed here? Yes, this CH3 is as it is. Next, CH3 is same. Here it is CH2OH plus H2O. Means reaction taking place only at COOH. Here also only at COOH. Changes to what? CH2OH. This oxygen is removed. Here is an, here see it is double bond O, correct? This double bond O oxygen is removed. To this double bond H2 is added. That is the reaction taking place. Here also same CH2OH. The name of this compound is, so listen, this is the parent chain is 2-methyl propanoic acid. What it is? 2-methyl propanoic acid. So here 1, 2, 3 carbon atoms are there. For the second carbon atom, methyl is. So this is 2-methyl propanol. 2-methyl propanol. Okay. No matter what is the R group here, the reaction taking place only at COOH group. Understood? This is what? Reduction of carboxylic acid. So the next is very important, acidity of acids. So students, acidity of acids means RCOOH is there. If it dissociates, what it will form? RCOO minus and H plus. So one which easily dissociate H plus, that is what? Acid. Okay. So this acidity is measured in pH. The acidity of acid is measured in pH. The equation for pH is minus log concentration of H plus ions. minus log of concentration of H plus ions. So listen, if pH is equal to 7, that is neutral. Correct? If pH is less than 7, acidic. If pH is greater than 7, base. Okay. The pH range is varies between what? 1 to 14. Okay. The pH is varies between 1 to 14. If the pH even it is very less than 1, that is very strong acid. Okay, and the pH which is greater than 14, that is strong base. Are you made right? Weak acid. Very weak acid. This is the range. If pH is equal to 7 neutral, pH is less than 7 acidic, pH is greater than 7 basic. So if pH is varies 1 to 14, even the pH is very less than 1, then it is very strong acid. If it is pH, so the pH is greater than 14, then it is very weak acid. Or when which is weak acid means it is a strong base. This is what acidity of carboxylic acid. So the main thing is what it is acidity means by the which nature they behave acidic nature means by the donation of the H plus ion. Okay, that's why they are acidic. That is measured in pH. This is the range. But the important thing is effect of electron withdrawing and the electron releasing group on the acidity of carboxylic acids. So students, here I will take both aliphatic carboxylic acid as well as aromatic carboxylic acids. So for aliphatic, I will take this one as the example. Okay, so electron releasing groups means what? Alkyl groups are the electron releasing groups. Except alkyl groups, one which having the greater electronegativity than carbon, those are all electron withdrawing groups. Understood? So carbon is there. Carbon is a 14th group element. After carbon, oxygen, nitrogen, fluorine and halogens, those are having high electronegativity. Understand? So which is electron releasing means alkyl groups CH3, C2H5, C3H7. Those are only electron releasing group. Except that alkyl compounds, each and every atoms which are having greater electronegativity than carbon are electron releasing. So here I will take CH3, COOH is there. First I will take electron withdrawing group Cl minus. Of course, Cl is not, it is always of affinity towards electron, it withdraws the electron. Then what happens? We are going to check the acidity of the acidity is due to what? Due to this carbon atom. Because this is the carboxylate ion, C double bond to OH. From this, we are going to check whether it is acidic or not. So students, remember, one which is accept pair of electron, what it is called as? One which accept a pair of electron, it is called as Lewis acid. One which donate a pair of electron, called as what? Lewis base. So in the case of acidity of alone carboxylic acid, we will take dissociation of H plus ion. If in the presence of electron withdrawing group or electron releasing group, we have to consider this acid and base concept. Lewis acid, Lewis base. Listen, this is electron releasing group. Okay. Initially we are taking electron withdrawing group. So I will take CH2Cl here. Understood? So this one have the capacity to withdraw the electron. This will withdraw from electron from where? From here. So here the electron density decreases. Okay. Next, this carbon to become stable withdraws the electron from here. Then here electron density decreases. And here also, then this withdraws electron density from here, here, here like that. Understand? So electron withdrawing groups are there. Then they decreases electron density on the carboxylate ion. If the electron density decreases, this one accept electron from here, this one accept electron from here. So this can accept electron from where? From the outer incoming species. So one which accept a pair of electron, what it is called as acid. So if the electron withdrawing group is there, then acidity increases. Understood? If the electron withdrawing group is there, then acidity increases. Acidic nature increases. Same if you take CH3COOH. This is the electron releasing group. It is always dissociated as CH3 plus. Plus means it has the capacity to donate an electron. So this easily donate electron here. So here the electron density increases. If electron is itself more, then it prefers liberation of electron than gain of electron. Understood? So one which has the capacity to donate a pair of electrons, that is what? Lewis base. Means if it is a base, acidity decreases. This is for what? Electron releasing group. So students, if the electron withdrawing group is there, then the acidic character increases. If the electron releasing group is there, then the acidic character decreases. Here it is increases, here it is decreases. Understood? If two or more electron withdrawing groups are like this. So in this, two CL atoms are there. Of course, this is also withdraw the electron, this is also withdraw the electron, means here the electron density keep on decreases. Then they require more and more electron. Then the acidic character increases. If the number of electron withdrawing group increases, then the acidic character increases. The number of electron releasing group increases, then the acidic character decreases. Understood? So I will write some. This one here, listen. CH3COOH is there. CH2COOH is there. Next, CHCl. COOH is there. And COOH. So students, here the number of, there is no, this is electron releasing group, this is one electron withdrawing group, 2, 3. As I told you, the number of withdrawing group increases, acidic character increases. So this is the correct order of increasing order of acidic character. Okay, next, for this as I told you, if the number of CH3 group keep on increases, electron releasing acidic character decreases. For example, HCOOH. Here there is no CH3 group. Next, CH3COOH. CH3CH2COOH. Okay? CH3COOH. Right. Here there is no electron withdrawing group. Sorry, electron releasing group. Here 1, here 2, here 3. So this is the decreasing order of acidic strength of the carboxylic acid. If number of R group, that is alkyl group, increases, acidity decreases. Electron releasing, withdrawing group increases, then the acidity increases. Understood? This is in case of what? Aldehyde. So if we consider aromatic, that is also same. Electron withdrawing group means the acidity of aromatic carboxylic acid increases, electron releasing means decreases. But the thing here is, so listen, carboxylic acid is, in both the cases, if withdrawing group is there, acidic character increase. If releasing group is there, acidic character decrease. That is the concept. So based on this, we can explain these two, nitration of benzoic acid and bromination of benzoic acid. Initially, I will say, right, if benzoic acid is there, the structure of the benzoic acid is C double bond OH. Okay? So in the resonance, Okay, these electron shifts here, these electron shifts here. Understood? These electron shifts here and these electron shifts here. So then what happens in the resonance? Here double bond C, single bond O, OH. Here we will get minus because electrons are shifted here, and here there is no electron, means here we will get plus charge. So in the resonance, plus charge is there. So students, you know that in the resonance we can get plus charge here. If the bond shift here, the plus charge may be here, may be here. So in ortho para position, we are going to get what? Plus charge. Ortho and para position, where the electron density is less. Okay? If plus is there, this must be minus. Understand? Here at the meta position, you know, this is ortho, this is para, this is meta. Okay, so in this position we can have the electrophilics. Here minus charge is there, electrophilic substitution takes this. Or you may easily think here the electron density is more, means the COOH group is a meta-directing group. Meta-directing group means the group one which direct the incoming species to the respective position. So initially in phenol and that I told you, so if phenol is there, if bromination it takes place, Br may be attached here or here. Ortho para substituted because OH is ortho and para directing group. But COOH is meta directing group because in the resonance if you write, you will get minus charge here in the phenol. That's why they form ortho and para product. Here the minus charge is at where? Meta position. That's why this is meta directing group. Electron density is more at meta position. So if the nitration takes place and bromination takes place, of course they form which type of compounds? Meta compounds. So nitration means what is the mixture here? Nitration means what we are going to take? Initially, sorry, always I told you bromination means bromine. We have to take. Chlorination means chlorine. Friedel-Crafts alkylation means CH3Cl compound in presence of aluminium, anhydrous aluminium chloride. That is Friedel-Crafts. Okay. Similarly for nitration, what I told? Nitric acid and H2SO4. The mixture of nitric acid and H2SO4. That is a nitrating mixture. Concentrated. Both are concentrated. Okay. So consider here benzoic acid. So here benzoic acid is there. These two are the ortho position. These two are the meta position. This is the para position. So when it is treated with nitric acid in presence of concentrated H2SO4, or you may say directly nitrating mixture. Mixture of HNO3 and H2SO4 is called as nitrating mixture. Then what is the product formed here? Here COOH. So this is the meta-directing group, means NO2 is going to attach here. Meta-nitrobenzoic acid. Understood? And so if you take bromination, in the bromination of course, this is COOH. That to be required. Correct? So here you may take FeBr3 as a catalyst. You may take FeBr3 as a catalyst. Then they form meta-bromobenzoic acid. Here the COOH to this meta position, bromine is attached. Meta-bromobenzoic acid. Only this is the only two here. And no matter whether it undergoes chlorination, sulfonation, anything, if carboxylic acid is there, aromatic especially, it is a meta-directing group. Whether it may be nitration, alkylation, acylation, bromination, chlorination, sulfonation, no matter which type of reaction it is. If that reaction, aromatic reaction is going to take place, always this is the meta-directing group. Meta product is the major product. Understood? Okay. So the last one, only one reaction is there, that is Esterification reaction. Named reaction it is, only for 1 marks they will ask. But that is removed from your syllabus. Then only I decide. Okay, that is chlorination of acetic acid. This is called as HVZ reaction. HVZ reaction. What is that HVZ reaction means? Well, HVZ means Elzinski reaction. Okay, so acetic acid means CH3 COH. To this Cr2 is added. Okay, so here we are using lead Pb, lead as a catalyst. So here it will form CH2 Cl COOH plus Lc. This is the reaction important for 1 mark. Actually, now it is removed. Then also, only this reaction is there. That is chlorination of acetic acid. Understand? Are soluble in water due to the formation of strong hydrogen bond. Some are insoluble in water. Understand? Due to the residues. And as it comes to boiling point, so because of the formation of the strong hydrogen bond, they are having high boiling point compared to aldehydes and ketones. In aldehydes and ketones, there is no free hydrogen. Here in OH, there is a hydrogen, free hydrogen it is. Understand? So due to the formation of a greater hydrogen bond, they have higher boiling points than aldehydes and ketones. Only these two are the physical properties. Understood? And this completes the chapter. Thank you.